on your paper it says a little bit more. It says factor using the GCF and fill in the blanks. All right, so the first thing we're going to do for something like this, if I want to factor this, is we're going to figure out what the GCF is. And how do we do that? We're going to start with a factor tree of each of those two terms. And we're just looking at the number part here, so we'll factor the 6. Don't worry about the C right now. How does 6 factor? 2 times 3, and those are both prime, right? And then how about the 15? 3 and 5. And those are both prime, so we're done with that. All right, after we have those factor trees, we're going to write the prime factorizations. So we're going to say 6, I'm going to do this over to the side here, 6 equals 2 times 3, and 15 equals 3 times 5, and then we're looking for common factors, yeah. So we're looking for what they have in common, and what's that going to be here? The 3's. So they both have a 3, which means then that the GCF is equal to what? What's the number part at least? Is it 3 or 9? It's 3. And then how about the variables? How many C's do they have in common? Do they have any C's in common? We have a C here in the first term, but there is no C in the second one, so they don't have a C in common. So what's the GCF? It's just 3, right? And what are we going to do with that GCF? We're going to start moving into this area model here. What are we going to do with the GCF? Where's it going to go? It's going to be the height. So we're going to label that as the height, and we're going to use that to figure out what the widths of each of those rectangles are going to be. So since that 3 is the height, I can put inside of the boxes 3 times something in both of them. So anytime we figure out what the height is or what the width is, this is what we want to do. We want to label that inside of the rectangles that are... We know the heights of both of these rectangles, but we don't know anything else, do we? We do know the areas of both of those rectangles. So this is set up, this problem's set up where the first factor here, the first blank that we're going to fill in is the height, the second one is the width, and then the problem that was given to us at the beginning, this 6C plus 15, that is the... This right here is going to be the area when we multiply the height times the width. So in all of these problems, when we're using these rectangle models, we're always using this formula, the area equals the height times the width. Now, it's flipped. We have the height and the width on the left side over here and the area on the right side, but it doesn't really matter. They're equal to each other. Okay, so either one can go on either side. So since these are the areas here, the 6C and the plus 15, we're going to put those in the rectangles here and here to show those are the areas. Now that we have the areas and we also had the height from before, now what can we do? Yeah, we figure out what do we multiply by 3 to get each of these things. What do we multiply by 3 to get 6C?
2C.
2C, and that 2C is going to be the... We know the height, we know the area, we were looking for the width. Okay, remember, it's always height times width and then the area. All right, what do we multiply by 3 to get 15? 5. All right, so that's going to be the width of that one. Put that up top. And then we can use that to fill in the blanks. Now, again, we're using this formula here. The area is the height times the width. This is the area, so over here we want the height, which is 3, times the width, which is 2C plus 5. Before we move on to the next one, I just want to show you something. I'm going to start with what we have here, what we got for our answer. So if I write that down here, what we got for our answer, it was 3 times 2C plus 5. If I gave you something like this and asked you to get rid of the parentheses, what could you do? This is what we used area models to do first, this triad. So we could distribute this. We could do it the old way, the way you learned in an algebra class before, and just multiply them out. And if we do that, or we could do it with an area model, but let's just distribute it the quick way here. What's 3 times 2C? 6c. What's 3 times 5? 15. Where do you see a 6c plus 15 here? This equation that I just wrote is exactly the same as this up here, right? So what we did when we factored is the opposite of what we do when we do the distributive property. Let's go ahead and do that with this one. We're going to start by finding the GCF again, and to find the GCF, what are we going to do first? Factor trees. Looks like 2 and 10, 5 and 2, 7 and 10, 5 and 2. So we write, what do we need to write now? Prime factorizations. So we're going to write 20 equals 2 times 2 times 5. And 70 equals 2 times 5 times 7. And then we're going to look for common factors. They have a 2 in common, it looks like, and a 5 in common, and that's it. So the GCF of the number part is 10. What about the variables? Do they have any variables in common? How many? 1D, right? So since this one has 2 D's and this one has 1, this one here can be matched up with one of these, and we have 1D in common. So our GCF is 10D. Where's that going to go? Over on the left, because it is the height. And then I can label the height in both of these here, 10D times something. And what else do I know about these rectangles? I know the areas, right? I know the area of this one is 20D squared, and the area of this one here is 70D. Now what? Okay. Yeah, so we're going to figure out what goes here. We can do it just by filling in the blank or by dividing. What do we multiply by 10 to get 20? 2. And if we have 1D here, we need 2 D's multiplied together. I need another D, right? A D squared? Just a D, right? So 10D times 2D is going to give us 20D squared. And then up here, what do I multiply by 10 to get 70? 7. And do I need any more D's there? No, because I already have the one that I need for my area. All right, so that 2D and the 7 are going to be my widths. Those will go here and here. And I can use that to fill in the blanks. Remember, it's going to be the height times the width. What's the height? 10D. And the width? 2D plus 7. Let's switch gears here a little bit, and let's go back to using this to distribute. So we're doing the same thing, at least using the same area model, but this time we're given the height and the width, and we need to figure out what the area is instead of the other way around. In the first two problems, we knew what the area was, and we used that to find the height and the width. Now we know the height and the width, we want to find the area. So if that 3a plus 4 is the height, where am I going to put those? Outside where? Top, left, right, bottom? Yeah, those are going to go on the left, and each of those terms is going to get its own row of rectangles. So this row of rectangles is going to have a height of 3a. This row of rectangles is going to have a height of 4. And then for our widths, this is going to be 2a and 5. Now what? Yeah, we actually have everything we need to find each of those areas, right? So what are we going to multiply to find the area of this one? Alejandro?
Multiply by 3a times 2a.
3a times 2a. So this 3a is the height, the 2a is the width, and we get an area of 6a squared. Okay. Kier, how about the next one? This one here. So the height is 3a, the width is 5, so we need to make sure we write those in there, 3a times 5, and that gives us an area of 15a. Carl, how about the next one? This one here.
4 times 2a equals 8a.
Okay, good. So the height is 4, the width is 2a, gives us an area of 8a. And then Niall, how about the last one? What's the height of this rectangle here, Niall? The height. How tall is it? height is going to be 4, and the width is 5. 4 times 5 gives us an area of 20. All right, so now what we're looking for here, since we have the height times the width in the problem, our answer is going to be the area. So we're going to be adding up all of these areas here. All right, when I do that, can I combine them all? No. So since I can't combine them, I need to make sure I write them in the correct order. And what's the correct order going to be? How do I decide the correct order? Biggest to smallest what? Starts with a P. Power. Right? So we're looking at the powers on the variables, and we're going to write them biggest to smallest. So the biggest power is this a squared here. So that's going to go first. Then the next biggest power is going to be the first power, which actually includes both of these, right? So what do we get when we add those together? It's 8a plus 15a. 23a, okay. And then the last one is the smallest power on the a, which is the one without any a's at all, and that's going to be the 20. And there's your answer. So our goal today is to be able to take something that looks like this without knowing anything else about it and figure out what the height and the width of the rectangles would be to give us this area. All right, so our goal today is to try to do this problem but backwards, to start with the area and get the height and the width. All right, so let's go ahead and get going here with an example. Let's start by filling out what we can in our area model. And there's not much we can do, especially because we didn't give you anything here. Before, we were telling you at least one of the heights, but we're not going to tell you anymore. So there's only a couple of things that we can put in here where we know it goes. What are those two things?
10e squared.
The 10e squared is going to be the area of the top left rectangle, and the 6 is going to be the area of the bottom right rectangle. What about that 23e? What's going to happen with that? That one's going to get split up between two different rectangles. The 23e is going to get split up between these two rectangles, but we don't know how much of it goes in each one. All right, so this one could be, and I'm just going to write this down just to show you what it could be. Could be 1e here and 22e here, right? That's a possibility. Or it could be 2e here and 21e here. Or it could be 3e and 20e, or 4e and 19e, or 5e and 18e. And there's a lot of different ways it could be, and we don't want to go through and try each one of these and see if it works, and then if it doesn't work, try something else. All right, so we're going to use what we learned yesterday, that MA stuff that we learned yesterday, 2 days ago, and we're going to use that for this. All right, now, the A part I think is pretty easy. We need to figure out what M is, and we need to figure out what A is. And since these two rectangles have to add up to 23, what do you think my A is going to be? 23. All right, so my A is going to be 23E. Technically it's 23E, but we can leave the E off. So we're looking for two numbers that add up to 23 between these two. The trickier one is the M. And I kind of gave a hint at this yesterday when we did the opener. The M is going to come from this one and this one. So the 23 gives us our A. The M is going to come from 10 and 6. What do you think I'm going to do with that 10 and 6 to figure out what M is? I'll give you a hint. M stands for multiply. So what do you think we're going to do with the 10 and the 6? Multiply them together. What's 10 times 6? 60. So our M here is going to be 60. Let's just forget about the area model right now. Let's forget about this expression here. Let's focus on this. We're looking for two numbers that when I multiply them together, I get 60. And when I add them together, I get 23. All right, so let's just start making a list of factor pairs. First one I'm always going to check is 1 and 60 in this case. Does that one work? Nope. So we cross it off and go on to 2. What do we multiply by 2 to get 60? If you don't know, what can you do? We can do 60 divided by 2, and then it gives us 30. Do those add up to 23? Nope. Okay, so that one doesn't work. Let's move on. Let's try 3. What do we multiply by 3 to get 60? 20. Does that one work? Yes. So this is going to be the numbers that work for M and A. And it also tells me how we're going to split up this 23E. What it tells me is that I'm going to say one of these areas is 3E and the other one is 20E. It actually doesn't matter which one's which. We can do it either way. If you do it one way and I do it another way, our answers are going to be the same. The only difference is the height and the width are going to be flipped. And there's nothing wrong with that. You can do it either way. What I usually do, and this kind of helps with stuff later, it makes finding the GCF, because we're going to have to use that today, a little bit easier, is I always put the smaller one here. So I'm going to call this 3 and 20, but there's a problem with what I did there. Anybody tell me what the problem is? This 3 here and this 20 here, they're supposed to add up to 23E, but without E's on the 3 and the 20, they just add up to 23, no E. So this needs to be 3E, and this needs to be 20E. So what we've done now is we've just filled in the areas. We still need to figure out what the heights and the widths are. And it's not really obvious how we're going to do that. So what we're going to do is, it's a little bit new. It's something we've done before, but we haven't done it this way, is we're going to just focus on one row. We're going to focus on this row right here, and we're going to factor that just like we did in the opener today. All right, so in the opener, if you look at the first 2 problems we did yesterday at the top of the opener, we did 2 problems where we factored just one row of rectangles using the GCF. Is that you, Olivia? Good. All right, so what we're going to do is we're going to find the GCF of 10E squared and 3E. Now, when we found the GCF, what we did is we started with we made factor trees for each of the numbers, and then we looked for what they had in common. We also looked for what variable they had in common, and then we used that to find the GCF. You don't have to do all of that if it's a simple one like this. And here's what I mean by a simple one like this. What are the factors of 10? How's that going to factor? 5 and 2, right? What are the factors of 3? 1 and 3, right? What do they have in common? Just 1, right? And if the numbers are pretty small like this, you can just kind of ask yourself, what do they have in common? All right, or if you're not as comfortable with it, you can come down here, make your factor trees. 10 is 2 and 5. 3 doesn't factor, so I'm just going to circle that. So we have 10 equals 2 times 5. 3 equals 3. And what do they have in common here? Nothing. And if they don't have anything in common, then what they really have in common is 1. All right, so the GCF there is 1, but then we also need to consider the variables. How many E's do they have in common? How many E's do they have in common? 1 in common, because this one only has 1 right here, right? So the GCF of 10E squared and 3E is 1E, and we're going to use that as the height. Now, since I know the height there, I can put that in this rectangle, and I can put that in this rectangle. And we should be able to finish all of this now just using that one piece of information that we just figured out. All right, so let's start here. What do we multiply by 1e to get 10e squared? 10e. And that 10e is the width. So I'm going to label that up top. And while I'm at it, if the width up here is 10e, where else is the width going to be?
Up in that right box.
No.
Oh, not that one. I'm talking about that one. The parentheses.
What other rectangle has a width of 10e?
Oh, okay.
The one directly below it, right? So let's go down there and put that width in there also. That's going to be something times 10e. Notice that I put the width second. So I left a space here for the height, which we don't know yet. And I put that width there. All right, now let's go to this one. The height is 1e. The area is 3e. So what is the width going to have to be there? That's going to be 3 because 1e times 3 is 3e. And so I can label that width up top. And what other rectangle has a width of 3? The one below it. All right, so if this rectangle has a width of 3, then this one does also. So this is going to be something times 3. Now, if we go to the bottom, we can fill in the blanks here. And if we did everything right, the height of this rectangle should be the same as the height of this rectangle, right? You guys agree that those heights should be the same? So let's check it out. What do we multiply by 3 to get 6? 2. Okay, so that should be 2. What do I multiply by 10e to get 20e? Just 2, right? So are the heights the same? Yeah, so we did everything right here, it looks like, because we have heights that match up, and that's going to be the height of this one. And we're done with the area model, right? So all we need to do now is to take the information that we have in the area model and transfer it to our answer. Now, when the problem was given to us, this is the area right here. So over here we're going to have the what times what? Height times width. So this one will make the height, which is what? 1e plus 2. How could I simplify that a little bit? Instead of saying 1e plus 2, I could say e plus 2. If you put the 1 there, that's okay. We're not going to take off for that, but you don't need it. And then the width is going to be 10e plus 3. Now, I want you to notice that we did this without having any information to begin with about the height, which we've been giving you. But we also did this without having to do much guessing. All of the guessing that we did was over here with trying out factor pairs until we found one that multiplied to 60 and added to 23. That's all the guessing you're going to have to do when we do it this way. All right, let's do another one together. We're going to do this example, and then we're going to write down the steps that would take to do this. All right, we'll do this one together. We're going to start by labeling the areas that we know. The areas that we know right now are what? So we have 10f squared is going to be the area of this one. The 6 is going to be the area of this one. Notice that those two areas there are the same as the two areas we started with here. But this time, this middle term here, this 19f, these are going to add up to something different, which means that this model is going to look a little different here. We need to figure out, though, how much of that 19 goes here and how much of the 19 goes here. It's going to get split up between those two. And what are we going to use to do that, to figure that out? We're going to use MA, right? So we're going to go off to the side. We're going to write M equals and A equals. Again, A is the easy one because I'm looking for two areas that add up to 19. That's going to be our A. And then what's M going to be? 60, right? So again, to get M, we multiply the first number times the last number. 10 times 6 is 60. So we'll start listing factor pairs now. 1 times 60, does that work? Do those add up to 19? No. So let's try another one. 2 times 30, we tried earlier. That doesn't work either, right? Then 3 times 20, that doesn't work because that adds up to 23. How about 4? 4 times what is 60? 15. Does that one work? Yep. So that's the one we're going to use to get our areas here. And again, I'm going to use the smaller one here just to keep things simple for finding the GCF. So this will be 4F here, and this is going to be 10F here. It's really important that, I'm sorry, not 10F, 15F. This is going to be 15F. It's really important that even though this is 4 and 15, these are going to be 4F and 15F. These need to have the F's on them because they need to add up to 19F. All right, now that we've done that, now that we know the areas of each of those rectangles, we're going to focus on just two of them. We're going to look at these two here and find what? What are we looking for? The GCF. I'm going to kind of give you a hint here. 10 is, if we factor it, we get 2 times 5. And 4, if we factor it, we get 2 times 2. So what do they have in common?
2.
They have a 2 in common. So the GCF is going to be 2. And then what else do they have in common besides the 2? We're looking at the 10f squared and the 4f.
Yeah.
They have an f in common. So the GCF is going to be 2f. That's going to be the height of that row that we're looking at. And since that's the height, where else can I put it? So that 2f that's the height can also go inside of the rectangles. So the height here is 2f times whatever the width is, and the height here is 2f times whatever the width is. And now that we have that, it should go pretty quick again. All right, so we have two pieces of information in each of these, so we can use those two pieces to get the third. What do I multiply by 2f to get 10f squared? What do I multiply by 2f to get 10f squared? 5. Do I need another f? Yes, I do. To make that f squared, I need another f. So that 5f is going to be the width. And since that's the width, what else has that same width? The one below it. So we'll go down there and we'll say this is something times 5f. And then over here, what do we multiply by 2f to get 4f? 2. So that's the width there, and the rectangle below it has the same width. Now, if you remember from the last one, if we did this right, the height here should be the same as the height here. If those heights are different, then this area model is not working out the way it's supposed to. So let's start here. What do I multiply by 2 to get 6? 3. What do I multiply by 5f to get 15f? 3. It's always nice when it works out, right? So since the height of both of those is 3, where else should I label that? Over on the side, on the left. And now we can use this to write our answer. Our area model's finished. So we can say that this area here is equal to the height times the width. What's the height going to be? 2f plus the height. The height is over here on the side. So 2f plus 3. And the width is going to be 5f plus 2. Before we move on, I just want to point something out. After we got this 4 and the 15 here, I decided to put the 4f here and the 15f here. But I told you earlier, it doesn't matter which one goes where. We could have put the 5 or the 15f here and the 4f here, and we would get the same answer. The only difference is if we do that, if I put the 15f here, then the GCF of these two would have been 5f, and we would have had a 5f here. And what would have happened is I would have gotten a 5f here, a 2 here, and I would have gotten a 2f here and a 3 here. So all that happened if we did that is the height and the width ended up getting switched. So if you switch it, instead of your answer being this right here, then your answer would be 5f plus 2 times 2f plus 3. And it's exactly the same, it's just switching the height and the width. And there's nothing wrong with that. You don't always have to have it in the same order. I'm always going to put the smaller one here, but you could put the bigger one here and it would just be switched. So, here's how you're going to do it. These are the steps that we took. So we figured out what M and A were, and we did that by multiplying the first coefficient and the third coefficient for M. Second coefficient gives us A. We figure out what numbers work for M and A. Using that, we write in the areas of all the rectangles, factor one row of rectangles using the GCF, and then we finish the rest. So in this problem here, let's go in the order that it says in the notes. So rather than starting by writing in the areas here and here, let's do all the areas at the same time. And to do that, we're going to need what we get from the MA method here. So what's M going to be? In the notes it says the first coefficient times the third coefficient. Do you guys remember what a coefficient is? So what's the coefficient here in the first term? The coefficient is just 4. It's the number in front of the variable. When we were talking about square roots, it was the number on the outside of the square root. When we're talking about variables, it's the number in front of the variable. So the first coefficient is 4. The third coefficient is 2. 4 times 2 gives us 8. What's A? 9. That's going to be the second coefficient, or the number on the second term. So we're looking for two numbers that when we multiply them together we get 8, and when we add them together we get 9. Let's start with 1. 1 times what gives us 8?
8.
Okay, does that one work?
Uh-huh.
Yep. It's nice when we only have to do one, right? So we're going to use that to help us with the area. Let's start with the 4g squared. That's going to go in the top left one. Then the top right and the bottom left, we're going to use this to decide how to split up that 9g. So the 9g is going to be 1g plus 8g. And then the last area is going to be 2. All right, now that we've done that, we're going to focus on just this row right here. And we're going to find the GCF. Now, there's not really much work to the GCF for this one. What's the biggest number that goes into 4 that also goes into 1? 1, right? There's nothing else that goes into 1, so it has to be 1. Now, what about the variable part? How many G's do they have in common? They do have a G in common, right? So we're going to put that out there also, so we get 1G there. That 1G is going to be the height of both of these rectangles here. Now what? Now that I know the heights of these rectangles, now I want to find the width. Okay, and the width is the number that I multiply by 1g to get 4g squared. What's that going to be? So we're going to multiply by 4, and then we have a g here, but we want to multiply by something to give us a g squared, so what else do I need? We have a g here, we want to multiply it by something to give us the g squared, so what else do we need? We need another g here, so that when we multiply g times g, we get g squared. So that 4g, that is the width of this rectangle, which means it's also the width of the rectangle below it, right? So the width of this one is also going to be 4g. All right, moving over to this one. What do we multiply by 1g to get 1g? 1. Somebody say 1g. If we multiply by 1g there, then we're going to get 1g squared, and we don't want that. It's just going to be 1, which means that the width of this one right here is also going to be 1. All right, now if we've done everything right, our heights here should be the same. The height of this rectangle is going to be what? What do I multiply by 1 to get 2? 2. What do I multiply by 4g to get 8g? 2. So that means that those match. The height there is going to be 2, and we're done with our area model. Now that we're done with the area model, this isn't one of the steps in your notes, but we still need to write our answer. So we're going to write our answer as the height times the width. What is the height of this rectangle? 1g plus 2. Instead of putting the 1 in front of the g, I'm just going to write g plus 2 because 1g means the same thing as g. And then the width of the rectangle is